Alright, this is pretty exciting. This is going to be the first video I've made for my Year 10s this year. It's a good question, this one. Solve these inequalities by multiplying by the LCD. Most of us haven't read that line. Here we've just got 1 plus x over 2 is less than x take 1 over 3. Find the solution. Z-man, or is it Z-man? I don't know. I gave someone 30 minutes. Angus, good man, came on and said, multiply the first side by 3 and the second side by 2 to cancel out the denominators, then work your way from there. I know that's what you sort of do. This side does end up having 3 multiplying the numerator, and this side has 2 multiplying the numerator. But if I just multiplied one side by 3 and one side by 2, well, if I multiply that first side by 3, the denominators it's not going to cancel with the denominator because I'd have 3 up the top and 2 down the bottom. And over here I'd have 2 up the top and 3 down the bottom. But I know what you meant to say. And this is where we're going to practice being precise. And this is really good because I know you would have got it right if you did the problem, and I'm sure you already have got it right. But let's have a look at what we actually do. And it tells us here, multiply by the lowest common denominator. That's the other little thing I'm just going to mention briefly. Read all the question. Don't jump to the maths. It's so exciting to go to the maths. I know you want to do the maths. I want to do the maths, but we have to do the little bit of boring reading first. Look at that. I'm getting so excited. I'm dropping my pen. But okay, we've got to do the little boring reading first. Make sure we get it right. Then we'll be fine. So here I've got an expression. I'm going to work over here on the right. That'll do. 1 plus x divided by 2 is less than x take 1 divided by 3. And yes, same as when we solve linear equations, and we did this just the other day. What do we want to do? We want to make our life easy. We want to get rid of those denominators. Don't cross-multiply, because cross-multiplication isn't doing the same thing to each side. What are we doing when we think we're cross-multiplying? We're multiplying by a lowest common denominator. When I do that, here I'm multiplying the first term by 6, and then I'm dividing by 2, so 6 divided by 2 is 3. So I've just got 3 outside of 1 plus x is less than, and on the right hand side the 3 goes into 6 twice, so it's less than 2 outside of x take 1. And that is what Angus was saying, the left gets multiplied by 3 and the right gets multiplied by 2. The numerators of the left and right get multiplied by those, but the whole thing, each side, is actually being multiplied by 6. We've got to multiply each side by the same number if we are going to maintain equivalence. And I've got those equivalent signs there, so I better maintain equivalence or I'd be a naughty liar. Expand the bracket. 3 times 1 is 3, and 3 times x is 3x. Less than, expand this bracket, 2 times x, and 2 times negative 1 is negative 2. Now it becomes easy. Let's actually put in the steps just to make it look nice. I'm going to subtract 2x from each side. I'm subtracting, I'm not multiplying by a negative, so I don't need to worry about doing anything with this sign. If I'm getting my x's on the left, I'm going to get rid of all these numbers from the left, so I've got to subtract 3. Let's subtract 3 from the other side. 3x minus 2x is x, less than, the 2x's are gone, negative 2, take away another 3, negative 5. What would that look like if I was drawing it? There's a 0, this is my x-axis. Here is negative 5. It's a less than, not a less than or equal to, so it's an open circle. And it's all the points going to the left of that point at negative 5. That was a good question. Lots of interesting things to talk about. We're going to tidy up our thinking so that we're crystal clear all the time. But that's really good. Good to see someone posting a question, Zach. Excellent to see someone answering the question, Angus. Keep up the great work, guys. I will see you tomorrow. Ciao.